We're starting our fourth course in our data science journey, and this is going to be an overview of cleaning data and preparing data for further analysis. And we'll get into some wrangling towards the end as well, but initially we're going to be talking about reading data into pandas, handling missing data, transforming data, and then string manipulation. Once again, I'm leveraging the course trajectory from Wes McKinney's book, Python for Data Analysis. And I'd recommend that you grab that book and use it along with this course material. Although I will say that the descriptions I'm giving here in most cases go beyond what Wes covered in his book. There are many ways to read data into pandas, but we're going to focus on reading the CSV file, since this is the predominant way in which data is brought into pandas. A lot of these other methods can be converted into a CSV. For example, in many SQL databases, you can just download all the data as a CSV. That's an option. However, there are a couple of useful methods here of interest. One is this reading clipboard. So basically, we can copy data from tables on a web page, and that copied data resides on our clipboard. And this method will bring that data right into pandas. Also, reading a table similarly. Also, reading HTML files. We can read all the tables found in an HTML document. Then if we're using APIs, obviously reading JSON is a very important capability that pandas has. But again, in this course, we're not going to go into all that. We're just going to focus on the CSVs. CSV files are comma-separated files. And it's such a predominant way in which data is imported that there are over 50 arguments that can be used with read CSV. And they basically fall into a number of different categories. There's arguments for indexing, for type inference and data conversion, for datetime parsing, for iterating over data. And so in this case, when we have large data files, we can bring it in chunks. And this method automatically converts those chunks into an iterable object. Finally, there's also ways to deal with extra information. We can skip certain rows or columns. We can deal with numeric data. For example, many large numbers in a CSV file are going to have commas with the thousands. You know, like for example, 1,000,000 is going to have 2 commas involved with that number, and we need to deal with that kind of anomaly. Well, first of all, we need to import pandas as a PD, and we'll bring NumPy in as well. And the first order of business here is this GitHub repository, which has a lot of the data samples that we'll be using here from Wes McKinney's book. Now, I will say that I have modified some of these, created some other ones, but if you go here, you can download this directly from GitHub. Just go here and hit this download button, and it will dump everything from that book into a zip file that you can save. I've done that here in my folder inside PyProj. Here's the data samples from Wes McKinney's book. I created another folder called data samples, and I've moved what I'm going to use out from this folder into here. So let's look at this syntax. Basically, we're calling this read underscore CSV and simply defining the file path. And this is in our root folder of PyProj from where we're running this. So it just goes directly into data samples, and from there directly to example 1. Let's bring this in as a table first. We'll execute this code. We'll compare that with the read underscore CSV method, and you'll see what happens here. We've not done any comma separating. Read table brings it in comma separated format. So this is just one column, but the CSV means comma separated values. So wherever there's a comma, it's going to create a new table. Even with the read underscore table method, pandas is already recognizing that there is a column head, and it respects that in the way it formats. Down here, however, we're retaining the column head. We're getting the default 0 indexed identifiers for each row.